Hello everyone, welcome for this lecture. Today we are going to continue with the last session, that is on AC circuits. We are applying all the techniques, basic techniques on that. Okay, so in the last class we have discussed till star delta transformations on AC circuits. Today we'll do mesh analysis and node analysis. Okay, uh, let's go to the numerical which they have given. Find the loop currents for the network shown below. They have asked us to calculate the loop currents. Let's find out. See, don't get confused with this arrow mark. Okay, so this is a circuit diagram which they have shown us. Okay, there is a 50 at an angle 0 volts voltage source, and here is also we have 50 at an angle 0 volts voltage source. This arrow mark they have mentioned it as for the reference. It means this is negative and it is positive. Since AC circuit has no polarities, so for our convenience we are going to take like this. Okay, so now we can take a two loop currents because there are two loops. Okay, so you can observe in the first loop will take a direction like this. Another one, let's take a direction like this. Okay, you can take an opposite direction, but you can now we'll deal with this and then we can discuss about that. Okay, so then in the first loop 2 ohm resistance is there. When you are coming down here you have a 3 and 5j ohm. So instead of going for this, we'll simplify this entire circuit as like this. Okay, 3 and 5j ohm resistances, this impedance is in series. There is R and XL. So we know when we have in the circuit, when we have R and L, we can calculate ZL as R plus J XL. Okay, similarly observe in this branch there is a 3 ohm resistance and minus 8j ohm capacitance. So we can calculate that Z impedance of this branch. You can take it as a ZC or Z1 Z2 also. ZC which is equal to R minus J XC. Okay, in this form we have to write. Let's write that. First one is a voltage source, another one is a resistance. This instead of R and L we will represent this as impedance. Okay, that is ZL, which is equal to 3 plus 5 j ohm. Okay, 5 j ohm. Next, another one will take a one more impedance. Okay, one more impedance, that is ZC, which is equal to 3 minus 8j ohm. Okay, 3 minus 8j ohm. Remember one thing, in the examination if they have specified minus 8j for the capacitor is well and good. If they are not mentioned, simply if they have given 8j, then also you have to take 3 minus 8j ohm. Okay, and then we have one voltage source which is of 50 at an angle 0. So this circuit we will be using. Okay, now for that we have to take a two loop currents. We need to calculate what is the I1 and what is the I2. Our intention is to calculate I1 and I2. So for that what we have to do is, let's apply KVL. Easily we can apply KVL for each loops. By taking we get a, since there are two loops, we get a two equations. When you solve two equations, you get two variable answer. Okay, that is I1 and I2. So let's solve that. Okay, yes, so there are two loops we have considered, I1 and I2. Let's apply KVL for the first loop. Okay, start with this 50 ohm. Okay, or yes, start with the 50 ohm, and from anywhere you can start. I have started from 2 ohm. Okay, 2 I1, right, plus 3 plus 5j. This is not only resistance, it is the impedance. So you have to take 3 plus 5j ohm. Okay, 5j, right. So 3 plus 5j into, this is the impedance, into what is the current flowing through this. Observe the direction of I1 and I2. Are they same or different? Okay, are they in the same direction or in the opposite direction? Both are entering like this only, so both are of same direction. So here we not supposed to take like I1 minus I2. Here you have to take I1 plus I2. This we have discussed in earlier classes also, right? I1 plus I2, and then we'll reach to a minus of 50. So minus 50 at an angle 0, which is equal to 0. Okay, and then simplify this. This is a 2 I1 plus 3 plus 5j I1 and plus 3 plus 3 plus 5j I2 equal to this, you can send this side, which is 50 at an angle 0. Simplify this, you can enter in a calci or you can directly write 2 plus 3 plus 5j is nothing but 5 plus 5j I1 plus 3 plus 5j I2, which is equal to 50 at an angle 0. Okay, let's call this equation number 1. Similarly, apply KVL for the second loop. When you are applying KVL for the second loop, let's start with this, or we can start with this. Okay, so let's start with this. 3 minus 8j I2, which is independent, plus 3 plus 5j I2 plus I1. You are in the second loop, but both the currents, loop currents, are entering to that branch. Therefore, I2 plus I1, and then you will reach to minus 50, which is equal to 0. So simplify this. 3 plus 5j I1 plus, say, simplify this. In a calci we enter 3 minus 8j plus 3 plus 5j. When you enter this, you get a 6 minus 3j I2, which is equal to this, and you can send that minus 50 at an angle 0 to right hand side, you get a 50 at an angle 0. So now we have got, this is your second equation. You have got first equation and as well as second equation. What we have to do is, these two equations, you cannot solve this one by calci. Okay, since these are complex equations. So what you have to do is, take those two equations. First one is 5 plus 5j I1 plus 3 plus 5j I2 and 50. This one, this is your second equation. What you have to do is, take a delta. Okay, take a delta which is equal to determinant. Okay, determinant of your current matrix, that is 5 plus 5j, okay, 3 plus 5j, right, 3 plus 5j and 6 minus 3j. Okay, take a matrix. You can write this entire equation, these two equations, in a matrix form, right? So that if you'd like to write this one in the matrix form, then it will be like this only. Okay, this coefficient of currents, which is I1 and I2, right, equal to your voltages V1 and V2. Okay, so in that equation we have to take a determinant of current coefficients. Okay, I1 I2, I1 I2, those equation, that matrix you have to get, and then it's find out the determinant of. Determinant is this into, that is this into this minus this into this, which is 5 plus 5j, okay, into 6 minus 3j minus, okay, take in another bracket, 3 plus 5j into 3 plus 5j. While calculating, you be careful in the calci. Okay, remember how many brackets you have to enter. Remember, for each term will be under a bracket. Okay, remember, for this to multiply, what we have to take is another bracket we have to take, and then close it, minus start with another bracket, and then anyhow these terms will be in a bracket, so close it. So be careful about it, and then you can take, which comes delta is equal to 61 minus 15j. Once if you have calculated delta, that is determinant of that matrix. Okay, next what we have to do is, we have to calculate delta 1. How we have to calculate delta 1? In that delta, okay, so if you would like to calculate delta 1, what you have to do is, first column, okay, first column has to replaced by your voltages. Okay, first column has to replaced by this after equal sign. Okay, so that is 50 at an angle 0 and 50 at an angle 0. So this column remains same. Okay, 3 plus 5j and 6 minus 3j remains same. So this becomes delta 1. Delta 1 will be in the delta matrix replaced of your first column. Okay, now you get same equation, same type of matrix. So find out this determinant, 50 at an angle 0 into 6 minus 3j. Okay, multiply this, minus multiply these terms. Okay, that is 3 plus 5j into 50 at an angle 0. So if you simplify this, you get 150 minus 400j as a delta 1. Similarly, delta 2 is what? You have to calculate delta 2. Delta 2 will be in the same matrix. okay, the same matrix. Second column will be replaced by this 50 at an angle 0, 50 at an angle 0. This remains same, that is 5 plus 5z remains same, 3 plus 5z is also remains same. Let's see that. Okay, first column as it is, second column will be replaced by your voltage sources, that is the right hand side of your equations. Okay, similarly calculate its both the calculate its determinant, this into, that is 5 plus 5z into 50 at an angle 0 minus 50 at an angle 0 into 3 plus 5z. So when you calculate this, you get a delta 2, that is 100 plus 0 I. What we have to do is, once you have calculated delta 1 and delta 2, what we have to do is, we have to calculate I1 and I2. I1 will be delta 1 divided by delta, and I2 will be delta 2 divided by delta. Okay, delta 1 we have already calculated, that is 150 at 150 minus 400j. This is in rectangular form. Okay, 150 minus 400j, and delta is 61 minus 15j. Calculate it, you get in the form of rectangular, and then that is delta 1 divided by delta we have to do, you get 3.839 minus 5.6j. Once you got this, convert that into a polar form. So that is I1 is equal to 6.8 at an angle minus 55.62 amperes. Okay, similarly I2 will be delta 2 divided by delta, which is delta 2 is what, 100, okay, plus 0 I divided by delta is 61.61 minus 15j. Once you calculate, you get in the form of rectangular, convert that, you get in a polar form, that is 1.59 at an angle 13.8 amperes. Okay, this is how loop analysis, mesh analysis can be done on AC circuits. So now we will find out node voltages for the circuit shown below. They have asked us to calculate what is the node voltage. Meaning of this one is, we supposed to apply KCL at each nodes, that is node analysis. Okay, so just observe before going to tackle with that numerical. So just observe the circuit how they have given. Okay, so this is, there is a resistance, there is a capacitor, inductance, and inductive reactance and resistances. So you have a current source, and here also we have a current source which is leaving, and here which is entering. So what we can do is, by observing this, can we replace these two and these two by a parallel equivalent circuit? Okay, so meaning of this one is, this is one current source, just simplify this, that is 5 ohm resistance and 10j capacitance are in parallel. Take its parallel combination, you get a impedance of it, that is, let's call this one as Z1, let's call this one as Z2, and let's call this one as Z3. What we can do is, Z1 will be what? Z1 will be 5 into minus 10j, whatever it may be, it is impedance. Okay, 5 into minus 10j divided by 5 plus minus 10j. Simplify this. Okay, here only thing is, concept source remains the same, applying procedures also remains the same. Only thing is, it takes a time to calculate, simplify. Okay, we should be bit careful and be friendly with your calculator, then easily we can calculate it. Okay, and similarly we can calculate Z2. Z2 is what? 5 minus 5j and 10j, which is minus 5j into 10j. Okay, take in a bracket and write it, and then minus 5j plus 10j. Simplify this, right? So similarly your Z3. Okay, so after calculating, you can get a simple circuit, which is, instead of resistance and capacitor, you have impedance Z1 after calculation, and then here you will be Z2, which is of a combination of capacitor and inductance, and then here one more impedance, you get Z3, which is a combination of resistance and inductance, and last one current source. Okay, so let's see how we can do it, right? So let's calculate Z1, Z2, Z3. After calculating and replacing all those values, you get a simplified network like this. Okay, for this network, you have to identify how many nodes are there, Okay, so this we can take one node, right? You can represent it as v1. So since one current source is entering, one impedance is there, and one more branch is there. Okay, so second we can take a v2 here, right? Third one we can say that this is our reference, v1, v2 and 0 we can take. So then we can apply KCL at each terminals. Okay, let's do that. Let's take v1, v2 and reference node. Okay, after calculating z1, z2, z3, you have z1 is equal to 4 minus 2j, and z2 is equal to minus 10j, z3 is equal to 2 plus 4j. You can observe this. First one is a combination of 5 plus 5 and minus 10j, and then second one is a combination of capacitor and inductance, that is minus 5j into 10j divided by minus 5j plus 10j, which is minus 10j. Z3 is equal to, that is third combination is of inductance and capacitor, 5j into 10 ohm resistance divided by 5j plus 10. So which after calculating it will be 2 plus 4j. These values you have to substitute on this network, and then identify your nodes. Okay, there are 3 nodes. So let's apply KCL at v1, apply KCL at v2. Okay, apply KCL at v1 and v2, you get 2 equations, and then we have to solve those 2 equations, we get an answer. Okay, let's deal with this. Apply KCL at v1. How many branches are there at v1? There are 3, 1, 2 and 3. Okay, so remember, among this there are 2 branches of our impedances, and one is independent current source, which we have to write on the right hand side. Okay, so now let's write impedances first. So let's take first branch, that is v1 divided by 4 minus 2j. Let's take this one in a bracket, plus this branch which is connected between v1 and v2, v1 minus v2. Okay, you are at a v1, therefore v1 minus v2 divided by minus 10j. Okay, equal to, remember, is this the current source is entering or leaving? It is entering, so we have to take plus 1 at an angle 0. Let's simplify. Let's take a v1 outside. There is 1 divided by 4 minus 2j, and plus, when you take a v1 outside, it will be 1 divided by minus 10j. Minus v2 is there, one more term, which is of minus v2, 1 divided by minus 10j equal to 1 at an angle 0. So let's simplify this. Take a calci, enter in a bracket, that is 1 divided by, one more bracket you take, 4 minus 2j. Complete this, and then there you take plus, start with the one bracket, 1 divided by, okay, take a bracket, minus 10j. Complete those 2 brackets. Once you calculate, you get this one, 0.2 plus 0.2j v1. Okay, similarly v2 also you can calculate, that is 1 divided by minus 10j. So it will be 0.1j v2, which is equal to 1 at an angle 0 is nothing but 1. So this is your first equation. I hope you know how to write the equation. By now you would have got it how to write the equation. Let's write together. Second equation will be, that is apply KCL at v2. Here v2 will be, at v2 it will be, there are 3 branches again, 1, 2 and 3. So 3 factors should be there. That 2 left hand side 2 branches, because these 2 are impedances, and 1 current source you have at the right hand side. Okay, let's write each. So first one is v2 divided by 2 plus 4j plus v2 minus v1. There is a minus 10j impedance between v1 and v2. You are at v2, therefore it should be v2 minus v1 divided by minus 10j, equal to independent current source we have, but it is leaving the node. Okay, if it is leaving the node, therefore it should be minus 0.5 at an angle minus 90 degree. Okay, please be careful about this minus. Whenever you are writing this term, you please write minus of 0.5 at an angle minus 90. Don't ever do like this, like minus 0.5 at an angle minus 90. It is wrong. Okay, this minus sign is for both, for 0.5 as well as real term as well as for the imaginary term. Therefore, don't ever write like minus 0.5 at an angle minus 90 degree. You have to write minus of 0.5 at an angle minus 90 degree. This is correct. This is wrong. Okay, so be careful about this term. All right, so simplify this. V2 you can take outside, will be 1 by 2 plus 4j plus V2 is one more V2 1 divided by minus 10j. Okay, we have a V1 also. We have a V1 also, which is V1 divided by minus 10j, which is equal to minus of 0.5 at an angle minus 90. Okay, simplify this. You get a 0.1 minus 0.1 j V2, and then this one you get a minus 0.1 j V1 equal to minus 0.5 minus of 0.5 at an angle minus 90. So write this. V1 I will write first, that is minus 0.1 j V1 plus this term, that is 0.1 minus 0.1 j V2 minus of 0.5 at an angle minus 90 degree. So this is your second equation. This is your first and this is your second equation. We have to follow to solve these two equations earlier method which I have explained. So take these two equations, write in the form of matrix, that is, let's take a delta. Delta means determinant of this coefficient of voltages. Now in earlier case we had taken a current because we had applied loop analysis or mesh analysis, right? So let's write determinant coefficient of V1 and V2. V1 is 0.2 plus 0.2 j, then V2 is minus 0.1 j, V1 minus 0.1 j, this one is 0.1 minus 0.1 j. Okay, let's take its determinant. While taking a determinant, this factor into this factor minus this factor into this factor. Okay, once you calculate, you get a delta is equal to 0.05 plus 0I. Okay, let's calculate a delta 1. What we have to do for delta 1? First column of this delta has to be replaced by your right hand side term, that is the current sources, which is 1 minus of 0.5 at an angle 90 minus 90 degree. Okay, this second column is remains same, minus 0.1 j and 0.1 minus 0.1 j. Okay, let's take its determinant again, this into this first. Okay, first term is this into this, and next minus this into this term. Okay, you can take like this also, minus 0.1 minus of 0.5 at an angle minus 90 degree. You be careful about this minus sign. Okay, once you do, you will get a delta 1 equal to 0.05 minus 0.1 j. Similarly, we have to do for delta 2 as well. What we have to do is, in this delta, okay, you have to replace this second column into this source, that is right hand side terms, 1 and minus 0.5 at an angle minus 90. Okay, first column will be remains same. Okay, then again you have to do, take this factor in a bracket and take this one is also in the bracket. Be careful how many brackets you have between these two, and multiply this factor into this factor, and then multiply this factor into this factor. You get delta 2 as minus 0.1 plus 0.2 j. Similarly, you can calculate V1 and V2. V1 can be calculated as delta 1 divided by delta. V2 can be calculated as delta 2 by delta. Delta 1 is 0.05 minus 0.1 j divided by delta is delta, and it is delta 1. 0.05 minus 0.1 j divided by 0.05. When you do it, you get first one is a rectangular form, which is 1 minus 2j. Once you convert into a polar form, that is 2.23 at an angle minus 63.4 volts. Okay, that is first node voltage. Similarly, you can calculate V2, which is delta 2 divided by delta. Delta 2 is you have calculated here, which is minus 0.1 plus 0.2 j divided by delta is 0.05. Okay, next you can calculate, you get a rectangular, that is minus 2 plus 4j. Similarly, you just convert that into a polar, you get 4.47 at an angle 116.6 volts. Okay, thank you.